All right, this is section 4.9, Fundamental Theorem of Algebra. All right, multiplicity has to do with the number of times each factor or root appears in a polynomial, okay? And then we talk about what it looks like on a graph. So it's the easiest way to solve a problem if you know how many times that root counts. So looking at this one, this has a multiplicity of 1. And the reason why I say this now, because when you see me solving these problems, you will see me use a graph. Okay, so here, this has a multiplicity of 1 when it just crosses normally like that. And that's your typical root or solution or 0, right? When it bounces off the graph, it counts twice. When it snakes along the x-axis, that counts 3 times, okay? All right, so by the way, though, technically, this is any even multiplicity, and this is any odd multiplicity. So it's not multiples of 3 multiplicity, it's odd multiplicity. So this could be 3, or this could be 5. This could be 2, or this could be 4. But here's the good news. For us, for all intents and purposes, it's going to be 2 or 3. I'm not going to give you something that has a multiplicity of 4 or something that has a multiplicity of 5. Okay? All right. So here's the fundamental theorem of algebra. If a polynomial has a degree of n, where n is positive, it should just say where n is not equal to 0. Then it will have n zeros or solutions or roots. Now, here's the thing. If the degree is negative, that's not a polynomial, okay? So it's redundant to say n greater than 0. All right, it should just be n is not equal to 0. Then we'll have n 0. Actually, this is not necessary, right? If n equals 0, then it has no solutions. Why do we have this? Okay. All right. So if a polynomial has a degree of n, then it will have n zeros or solutions or roots. So if it has a degree of 0, it has none. It has no solutions or roots. If it has a degree of 1, it has 1, 0 solution. Okay? All right. And this is the rational root theorem. Okay? This is called the rational root theorem. And this is how you do it. Factors of the constant term over factors of the leading coefficient. This is the possible. So we're going to do this one real quick. We're looking at the possible rational zeros. So this is a throwback to when they didn't have a calculator and you had to figure out what are the possible answers. Okay, and here's how you look at it. You look at 6. 6, I'm going to take up space over here. So 6 has the possible factors of 1, 2, 3, and 6, right? All 4 of those numbers go into it. And then you look at the leading coefficient of 10. And the possible factors there are 1, 2, 5, and 10. And then what you're going to do is put the possible factors of 6 over the possible factors of 10. So the possible solutions are, you're going to put all of these over 1. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Right? All I did was put 1, 2, 3, and 6 over 1. Now I'm going to put 1, 2, 3, and 6 over 2. So it's plus or minus 1/2, plus or minus 2 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. Now, you might be thinking, oh, but you're always telling us to reduce our fractions. Yeah, you can go ahead and reduce it. Yeah, I don't care in this case. And the reason why I don't care is because it helps keep things straight in your mind what you're doing. When I start reducing, I lose track of what the heck I was working on, and I was like, well, why is this a 3? I have a 3 over here. Why is this a 1? I have a 1 over here. So when you answer this question for me, if you have repeat answers, I don't care. All right. So I'm only halfway done because I've done 1 and 2. Now I got to use 3. No? What did I do? Oh, I'm sorry. See, I'm already getting lost. I'm using all of those on 2. That's what I've done. I've used all of those on 2. I'm not going to use all of those on 5. So it's plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, and plus or minus 6/5. All right. And now I'm going to do 6 over all of those. So it's plus or minus 6. No. All of those over 10. God, see, it's very easy to get confused. So I'm going to do all of those over 10. So it's plus or minus 1/10, plus or minus 2/10, plus or minus 3/10, and plus or minus 6/10. Okay, and yes, they can be reduced. So like 2/10 here is the same as the 1/5. But to keep it straight in my mind and to keep track of how many I should have, right? It should be this many, which is 4, times this many, which is 4. So 4 times 4 is 16. I have 16 possible solutions here. And yes, some of them overlap. Okay, several of them overlap. All right. But that's all this is asking you to do, to find the possible rational zeros for each polynomial. Here's the bad news. You can actually have none, right? You can have none. If you have no rational zeros, then you're kind of screwed. All right. Let's do the next one. All right. So here we have 1, which is only 1. And so we're looking at this one, right? And 8, which is 1, 2, 4, and 8. So this one's easy because there's only one number to put over all of these. So you just do plus or minus 1, plus or minus 1/2, plus or minus 1/4, and plus or minus 1/8. So that's it. That's all you're doing there. All right, find all the possible zeros for each polynomial. Okay, this is not all the possible. This is find all the zeros for each polynomial. Okay, so this is just a throwback to gobbledygook stuff. All right, let's do A. All right, and we're going to do this on the calculator. Okay. Hopefully this is dark enough or light enough. All right, so I'm going to just put this in the calculator. All right, you can use decimals, but I have no way of recording decimals on here, so I'm going to use calculator. Y equals, let's put that in there, x to the 4th, x to the 4th, minus 5x cubed, plus 3x squared, plus x, enter, graph. All right, looks like there's an answer at 0, and let's see what that answer is. So I'm going to use calc. I'm using trace, and that is I'm looking for the 0. So I'm looking for choice number 2, and I want to find this one, not the one at 0, 0. I want to find that one. So I'm going to go a little bit to the right. That's there. Press enter. And then go on the other side of that. That's good. Oop, too far, but it's okay. Press enter. Then press enter. And it gives me 1. Great. All right. So what do I do there? All right. First of all, there's a common factor of x. So that's where that 0 comes from. The common factor of x is producing that 0 right there. So I'll take a x out. That gives me x cubed minus 5x squared plus 3x plus 1. Okay, so x equals 0. This one gives me x equals 0. Now, I notice we found out using the calculator that 1 is a solution. All right, so I'm going to do that. So I'm going to plug 1 in. What am I getting here? Not plug 1 in. So I'm going to do synthetic division on this one, the cubic, instead of the 4th degree. I'm using it on the 3rd degree. 1, negative 5, 3, 1. So 1 times 1, negative 4, negative 4, negative 1, negative 1, 0. Okay, then I have this, which would be x squared minus 4x minus 1, at which point I have to use the quadratic formula. Remember, the quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. A is 1, B is negative 4, and C is negative 1. So it's going to be opposite of negative 4, so it's 4 plus or minus square root. Negative 4 squared minus 4 times 1 times negative 1, all over 2 times 1. Scooch you on over. So that's going to be 4 plus or minus square root of 16 plus 4 over 2. All right, and let's go over here. So it's 4 plus or minus square root of 20 over 2. And 20 is 2 and 10, 2 and 5, so there's a pair of 2's. So it's 4 plus or minus 2 root 5 over 2. And you can reduce. Whenever you reduce a fraction that looks like this, you have to reduce all 3 parts. And the radical doesn't count. Okay, so all 3 parts. So 2 goes into 4, 2, and the denominator of 2. So that becomes 2 plus or minus root 5. All right, so let's see what our answers are. We have 2 answers here, 2 plus or minus square root of 5. And we have the 1, right, we found using a calculator. And 0, we found using factoring, right? So we have, so let's formalize our answer here. We have x equals 0, 1, and 2 plus or minus square root of 5. Those are our 4 answers. 1, 2, and that plus or minus counts twice. So that's 4 answers. And we were expecting 4 answers because the degree is 4 by the fundamental theorem of algebra. If a polynomial has a degree n, in our example, our degree is 4, so we're expecting 4 answers. All right, moving on. Let's do this one. I'm going to put this in the calculator as well. All right, clear that out. X to the 5th plus x cubed plus 2x squared minus 12x plus 8. All right, graph that puppy. All right, so here, let's find that one. We can find that one. Either one, we'll find either one. All right, this is x to the 5th. There's only 2 obvious zeros. Well, I don't know if that's obvious. Let's see if that's one. All right, so first let's find that one. I don't know if that actually crosses the x-axis. So we're going to do second calc. And we're going to find a 0. So that's choice number 2. And by the way, if you're using Desmos, I mean, you're welcome. I mean, Desmo, you just click on that point and it'll tell you, okay? Oops, that's too far. Press enter, then press enter. And I got, so that 1.0002 is just 1, right? So calculator cannot get exact. When you do it on Desmos, it'll just give you 1, 0. All right, so that's 1. So I have x equals 1 as a solution. All right, x equals 1 as a solution. But here's the weird part. Remember what we talked about up here? When we talked about multiplicity? So it bounces off, so that means it counts twice. What does that mean when solving these problems, when it counts twice? And I'll show you what it means. All right, so first we're going to do synthetic division. So it's 1, right? That's the one I'm plugging in. That's the one I'm dividing by. All right, so my coefficients are 1, and this is missing the x to the 4th. So I got to put in the 0, and then the 1, the 2, the negative 12, and the 8. Now, so, right? So 5, 4, 3, 2, 1, none. Okay, I'm just double checking. Check my signs. All right, bring down the 1, multiply 1, 1, 1, 2, 2, 4, 8, negative 4. Why did I get 8? It's a 4. Goodness. 1 times 4 is 4. I don't know why I wrote 8. Okay. And negative 12 plus 4 is negative 8. Negative 8 times 1 is negative 8. 8 plus negative 8 is 0. All right. Now, so I did it once. Now I'm going to do it again with the same number. I'm doing it again with the same number. All right. So bring down the 1. 1, 2, 2, 4, 4, 8, 8, 0. Okay, so what I did was bring down the 1. 1 times 1 is 1. Add. 2 times 1 is 2. add, bring up to 4. 4 plus 4 is 8. 1 times 8 is 8. Add. All right. So now I got 1, 2, 4, 8. So my goal is to get 3 numbers here. I still have 1 too many. So I'm going back to the calculator. That means I got to find what this root is. I've got to find what that root is. All right, to do that, I'm going to use second calc again. All right, so second calc. I'm choosing number 2, the 0. And I need to go to the left side. So it's going to take me a while to get over there. Oops, did you see that? Where is it? Huh? There we go. There it is. But I need to move it to the left. So I'm using the left arrow button. I want you to notice something. Up here, the y value is 5.5. Now moving it to the left, it jumped to -10. So I know I went to the right direction. Okay? Press enter. Now I'm going to the right. Now it's positive. That's the biggest thing you want. You want the signs to change when you're doing this left and right bound stuff. Press enter. Press enter. That's value of -2. So if you see something that looks like this with an E in it and a negative number after the E, that's basically 0. So it's -2, 0. So that means I'm going to plug in -2. So this was x equals 1, and it had a multiplicity of 2 because it bounced off. That's why I was able to use it twice. That same number, use it twice. Now I found another 0 at x equals -2. So now I'm going to use x equals -2 in here. Onto this one, the 1, 2, 4, 8. So 1, 2, 4, 8. So that's 1. -2 times 1 is -2. 0. -2 times 0 is 0. 4. -2 times 4 is 8. Oops, -8. So that's 0. And I didn't show it to you. Dadgummit. All right. So I'll do it again. So I wrote 1, 2, 4, 8. Right? That's this number's down here. I was running out of space, so I copied it to the right. I'm using -2. That was a 0 I found. Bring down the 1. -2 times 1 is -2. Add. -2 times 0 is 0. Add. -2 times 4 is -8. Add, and I get 0. So now I have, so remember, if you have 3 terms, that's going to be x squared plus 0x plus 4 equals 0. Okay, so let's get rid of that 0x. So it's just x squared plus 4 equals 0. Now you can use regular solving to solve that. So you go subtract 4 to both sides. You get x squared equals -4. So x equals plus or minus the square root of -4. So x equals plus or minus 2i. Okay? So there's 2 answers there, the plus or minus. So let's put the answers here. So we have x equals -2. Right? And we have x equals 1. Counts twice, so it's a multiplicity of 2. And we have plus or minus 2i. So that's 1. The -2 is 1. The 1 counts twice, so that's 1, 2, 3. And the plus or minus 2i counts 2 more. So 1, 2, 3, 4, 5. And I was expecting 5 answers. All right? That's it. Excuse me. I guess I didn't need to record that, huh? All right. I'm going to do the other 2 on a different video because this video is getting long now.